Good morning. It's September 10th, and this is your daily brief in science. Here's everything you need to know. Prochlorococcus, a key phytoplankton species responsible for a significant portion of marine oxygen production and supporting ocean food webs, faces a potential decline due to rising sea temperatures. New research indicates that even heat-tolerant strains may not fully offset the impacts of ongoing global warming, with projections suggesting possible declines of up to 51% in tropical regions under severe warming scenarios. Under moderate warming, the productivity of Prochlorococcus could decrease by 17% in the tropics and 10% globally, which threatens its vital role in ocean ecosystems. The study combines real-time measurements of chlorophyll fluorescence and cell size with ecosystem-scale modeling, providing detailed insights into microbial responses. Critics question whether surface water samples accurately reflect the organism's ability to survive at higher temperatures, noting that a decline in division rate does not necessarily mean extinction. The research highlights that the sharp decline in division rates beyond 28 degrees Celsius may be due to enzyme denaturation and impaired photosystem function, emphasizing the need for further mechanistic studies. Limitations include the focus on surface waters up to 8 meters deep, leaving uncertainty about responses of deeper, cooler populations. Researchers also acknowledge that undetected heat-tolerant strains could exist, which might offer some resilience. The potential loss of Prochlorococcus could have cascading effects on marine biodiversity and fisheries, as its resilience may be limited despite some genetic plasticity. While other phytoplankton might partially compensate, they are not perfect substitutes due to Prochlorococcus's specific adaptations. Overall, the findings underscore the vulnerability of ocean microorganisms vital for climate regulation and highlight the importance of further research into deeper water layers. Recent research from Penn Medicine shows that exposure to high levels of air pollution, particularly fine particulate matter known as PM2.5, can accelerate the progression of Alzheimer's disease. The study found that increased pollution exposure correlates with more amyloid plaques and tau tangles in the brain, which are hallmarks of the disease. Conducted over a period from 1999 to 2022, the research analyzed data from over 600 autopsy-confirmed cases, adjusting for factors such as socioeconomic status, demographic variables, and genetic risk factors like APOE4. Researchers modeled individual pollution exposure based on residential location, using satellite and local air quality data, though they could not account for personal exposure variations, such as secondhand smoke or occupational hazards. The study emphasizes that nearly half of Americans continue to face dangerous pollution levels, especially in wildfire-prone areas, near highways, and in industrial zones. Higher PM2.5 levels were linked to a faster onset of clinical symptoms, including memory loss, speech difficulties, and impaired judgment, with those exposed experiencing more severe cognitive decline. Experts highlight that environmental justice initiatives aimed at reducing air pollution could help lower neurodegenerative disease risks. The research also suggests that air pollution impacts the brain through multiple pathways, including effects on cardiovascular and cerebrovascular health, which may indirectly worsen Alzheimer's pathology. Despite efforts to improve air quality, the findings underscore the importance of policy changes to protect vulnerable populations. Limitations of the study include a demographic skew in the autopsy cohort and the inability to account for other pollutants like nitrogen dioxide and ozone. Astronomers have identified a gamma-ray burst that defies current understanding, designated GRB 250702b. This event lasted about a day, far longer than typical gamma-ray bursts, which usually last seconds to minutes. It was first detected by NASA's Fermi Gamma-Ray Space Telescope on July 2, 2025, and subsequent observations confirmed its repeated bursts and extended duration. Most gamma-ray bursts are linked to stellar collapse or black hole activity and are short-lived, making this event an outlier. Initial data suggested the source was within the Milky Way, but advanced telescopes like the Hubble Space Telescope and the Very Large Telescope confirmed it originated from an extragalactic galaxy billions of light-years away. Follow-up observations refined the event's location and indicated an extremely energetic explosion. This discovery points to a possible new class of long-lasting, repeating gamma-ray bursts and raises questions about stellar death processes and black hole interactions. Researchers are considering explanations such as a tidal disruption event involving a white dwarf and an intermediate mass black hole, which could explain the periodicity and energy. Multiple telescopes are being used to study the event further, as its exact origin remains unidentified. Ongoing observations with the James Webb Space Telescope and VLT aim to clarify the progenitor, but no definitive explanation has emerged yet. The event's features, its duration, repeating bursts, and X-ray activity, do not fit standard models of gamma-ray burst progenitors. Scientists suggest this could be a new type of cosmic object or a rare phenomenon, revealing gaps in current astrophysical knowledge. Overall, this discovery highlights the importance of multi-telescope observations in unraveling cosmic mysteries and may reshape the understanding of gamma-ray bursts. A new UK-wide longitudinal study called Generation New Era aims to track up to 30,000 children from birth to better understand their development amid societal changes. The study, scheduled to begin recruitment in autumn 2025, is funded by UKRI and the ESRC with a budget of £42.8 million. It involves multiple universities, including UCL, Swansea, Ulster, and Edinburgh, and seeks to include underrepresented groups and fathers to ensure comprehensive UK-wide representation. Data will be collected when children are 9 to 11 months old and again at 3 to 4 years old, with plans to follow participants throughout their lives. Researchers hope this will inform policies and improve outcomes for children across the UK. Experts like Professors Goodman and Fearon highlight that this infrastructure will help understand factors affecting children's health, mental well-being, social development, and educational needs, especially among disadvantaged groups. UK Research and Innovation notes that the UK has a proud history of cohort studies that have contributed to health, education, and social policy improvements, such as reducing childhood mortality and increasing literacy. Past studies have influenced policies like extending parental leave, enhancing mental health support, and addressing educational gaps for summer-born children. The new study will create a valuable resource by linking data to health and education records, aiming to improve future outcomes for children and families. It emphasizes inclusivity by actively engaging fathers and underrepresented groups, ensuring diverse demographic participation. Participants will also contribute saliva samples for genetic analysis to explore links between genetics, diseases, and health outcomes, making this one of the first UK cohorts to incorporate genotyping from the start. The study aims to address societal changes since the last major birth cohort in 2000 and aims to inform better policies for children's lives. Historically, UK long-term studies have led to significant scientific and societal advancements, including reductions in smoking during pregnancy and improvements in literacy and mental health. Parents of babies born in 2026 will be invited to participate through letters sent in autumn 2025, with data collection at 2 key stages and a lifelong follow-up planned. Britain is conducting trials on a new blood test for Alzheimer's disease that could significantly improve diagnosis processes. This test measures levels of p-tau217, a protein associated with Alzheimer's, and shows accuracy comparable to PET scans and lumbar punctures. Currently, only about 2% of patients undergo these expensive and invasive tests, which are rarely used due to their cost and complexity. The trial assesses patients at various stages, with some receiving results within 3 months and others after a year, to determine if earlier results can speed up diagnosis and decision-making. The new blood test is expected to be more accessible and cost-effective, costing around £100, and could potentially improve diagnostic accuracy from 70% to as high as 90%. Early and precise diagnosis is crucial for accessing treatments and support, especially with new drugs that can slow disease progression if administered early. Experts like Professor Jonathan Schott and Dr. Ashvini Keshavan believe this test could enable earlier, more widespread diagnosis, which is essential for better patient outcomes. Professor Schott also noted that the test could help differentiate Alzheimer's from other causes of dementia, such as depression or sleep issues. Given that dementia remains the leading cause of death in the UK and many cases go undiagnosed, this test could have a significant public health impact. It offers a promising alternative to current diagnostic methods, which are costly and underutilized, and could transform how dementia is diagnosed and managed. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.